Moving on to section 4.4b, proving triangles congruent by side, angle, side. That's what SAS means. Okay, so here's what it means. I'm going to zoom in, and I'm going to trace right over these angles. Okay, so my pattern will be side, angle, side. Side, angle, side. The angle, which is angle B here and angle E here, is always right in between these sides. So when I look at my triangle and read it, so if I just read it, side, angle, side. If I go down here and I start with, if I start with this one where I'm putting my black arrow, side, and then I go here, there's nothing here, nothing here, nothing here. So I can't go in that direction. What I've got to do is I've got to start here and go side. My next thing should be angle, and my next thing should be side. So I can see that these two triangles are congruent by side, angle, side. The big key is that the two sides basically have to sandwich the angle. Okay, here's some examples. Okay, and I'm going to zoom into this picture. It's kind of hard to see with the hang glider, but I'm going to show you how side, angle, side can work. All right, so our first given is that FG is congruent to GH. And we are going to mark these in red so you can see them. But FG is congruent to GH. And I'm trying to get these two triangles congruent. Okay, let me outline them in black so you can see them. These are my two triangles. Okay, my other given, I'm going to keep zooming in and out here. JG bisects FGH. Okay, if JG bisects FGH, we can conclude that angle FGJ is congruent to angle HGJ. And you guys will not have to do this on the test, quiz, homework, but those are now congruent. Now, I'm trying to do side, angle, side. I have a side and I have an angle. I need to find another side. My only other side that's going to work has to be this one right here. Any other side would not give me the side, angle, side pattern. So all I'm going to say here is that JG is congruent to JG because those triangles touch each other. And now this has a side, angle, side pattern. So if you guys see a picture of this, you should be able to see that the pattern is side, angle, side. Okay, let's try another one. Okay, in this one, we're trying to prove these two triangles congruent, a little bit easier to see. V is the midpoint of YZ. If V is the midpoint of YZ, then YV is congruent to ZV. And I'm going to mark my triangle. Okay, then it says V is the midpoint of WX. Well, that will tell me now that WV, because it's the midpoint, is congruent to XV. And I'm going to give my 2 marks. We are looking for side, angle, side. The only other angle that could work to make this a side, angle, side, it has to be the angle in between the two sides. And it's right here. How do I know that those angles are congruent? I'm going to say that angle YVW is congruent to angle ZVX. And if you guys remember vertical angles from earlier this year, because those are vertical angles. I can mark them congruent, and now I have a picture that represents the side angle side congruency pattern, and that's how I know my triangles are congruent. All right, we have one more here. Okay, my picture is already marked. NP is congruent to MP, but I will trace over it so you can see it. Okay, NM is perpendicular to PL, so then I have congruent angles there. Angle LPM is congruent to angle LPN, because all right angles are congruent, right? Because they're right angles. And lastly, I need to find the side. It has to be this side. Why is it that side? To make it side angle side. So segment PL congruent to segment PL, and that will give me the side angle side pattern